Hello again, this is Mr. Minnick. This is a math module. This particular module, we're going to be talking about what it means for a radicand to be in simplest radical form. Simplest radical form. Simplest radical form. So, in another module, we talked about the radical sign. And in geometry and algebra 2, and pre-calculus and calculus, a lot of times you have to simplify radicals. Simplest radical form, there's several conditions that have to be met. One of them is the radicand. The radicand. Now remember, that's the number under the square root symbol. The radicand has no perfect square factors larger than the number 1. Okay? So in other words, you have to kind of consider the factors of the radicand. You have to know your perfect squares. If there are any factors in the radicand that are larger than 1, then what we're saying is the number is not in simplest radical form. Okay? The other condition that's got to be met is that any and all like radicals are combined. Perhaps in another module we'll discuss what a like radical is. It's similar to a like term. Like terms have the same variable, same exponent. We'll find that like radicals have the same radicand. They have the same radicand. Okay? So any and all like radicals are combined. I said there were several conditions. Really, there's only one more. The third and final condition here is that there are no radicals in the denominator. No radicals in the denominator. In pre-calculus and in trigonometry, you study the unit circle. Sometimes in algebra 2 you also do. And you have to take the square root of 1 over the square root of 2, and you find that it's 1 over the square root of 2, and that's bad. And you're not allowed to write the answer like that, okay, because that's not simplest radical form. And you end up writing the answer a little bit different. Okay? In a later module, we will be looking at how to handle that, but so that's not in simplest radical form. Okay? So what we're about to do then is look at several examples and figure out whether or not they are in simplest radical form. So here we go. Is each expression in simplest radical form? I'm using abbreviations. Is each expression in simplest radical form? So we'll look at the number the square root of 10. We'll look at the number the square root of 48. We'll look at the square root of 6 plus the square root of 7. We'll look at the square root of 7 plus the square root of 8. And we'll look at the square root of 8 times the square root of 3. Okay. So if we look at the first one, the square root of 10, we said, well, the first thing we got to do is look at the factors of the number. So being able to find factors is a crucial skill. 1 and 10, 2 and 5. And the question is, are any of those perfect squares bigger than 1? And the way that you answer this question is kind of counterintuitive. If the answer to that question, are any of those factors perfect squares bigger than 1? If the answer is no, then yes, it's in simplest radical form. So let's see. 1's a perfect square. None of the other factors are. So is this expression in part A, is it in simplest radical form? Yes. Yes, you cannot simplify it any further. Yes. It's in simplest radical form. So let's look at number B here. I know B's not a number. Is B in simplest radical form? Is B in simplest radical form? I'm saying people shake their head no. No is the correct answer, and the reason it's not is because there are perfect square factors bigger than 1. For instance, 16 and 3. 3 times 16. Because of that 16, It's not. Also, because of 4 times 12. Because of 4 times 12, it's not. Okay? So the one in part B is not in simplest radical form. Let's look at part C. Part C. Rad 6 plus rad 7. Like radicals have the same radicand. Our radicands are 6 and 7. They're not the same. What do we think about C? Are those in simplest radical form? Is that in simplest radical form? Believe it or not, it is. We don't have any like radicals to combine. Yes, that one's in simplest radical form. Okay. Number 7. Number 7. Number 8. What do we think about 8? Somebody said no. You're right, it's no. Since 8 has a perfect square factor bigger than 1. 8's really 2 times 4, and 4 is a perfect square bigger than 1. So that's why that one's not. Okay? You might be wondering about anything even. A lot of times with questions that are even, we want to think, well, that could be simplified. It has nothing to do with it being even or not. It has to do with the factors. If we look at the factors of that particular one, the factors are perfect. We're looking for perfect squares bigger than 1. 2, 5, and 10 are not perfect squares. Okay? So it has nothing to do with whether it's even or not. It has to do with whether the factors are perfect squares. Okay? Part E is going to lead into a different module. Part E, there's actually a property that we'll talk about in a minute in another module. This ends up being the square root of 8 times 3, or the square root of 24, and of course 4 is a factor, so this one is a no also. Okay. So simplest radical form might be a little confusing. If you need more assistance, please see one of your regular teachers on that. So it's been real, it's been fun, and that's it for this module.